Thank you for having me today. I'm Bill Eubank with Cold Spring. We are in the fabrication and quarrying of granite materials. And I want to talk to you about granite. But first, I'll introduce myself. I've been in the stone industry almost 30 years, so please use me as a resource. I live in Richmond, and I cover DC, Virginia, and the Carolinas, so I'm up in DC in the neighborhood probably more than you realize, up there working on projects and so forth. But again, I've been with Cold Spring over 5 years and in the industry for almost 30. So if there's any type of stone that you're considering, if we don't do it, chances are I might know about it and can point you in the right direction. So I'm going to go ahead and share my screen now and start the PowerPoint. What I'd like to do is tell you a little bit about Cold Spring and introduce you to our company, and then we'll switch over into continuing ed. So are you familiar with Cold Spring, anyone? But we're a national company, and we're headquartered in Minnesota, and we own and operate quarries throughout the U.S. and a couple pits in Canada. We have them in New York, Texas, Minnesota, South Dakota, California, and then we have sales reps throughout the country to service projects through design, construction, and so forth. A couple shots of our quarries. You can get an idea of the scale of these operations. We're going to be talking more about this in the continuing ed portion of the program. It doesn't matter if you have a major multi-million-dollar stone package. We're very capable of handling that. Someone's got a little background noise. You may want to mute. All right. It doesn't matter if you have a very large project. We're capable of handling that, but we're also capable of handling.
I was wondering.
Sorry, can everyone mute, please?
Is like he's now doing algae. How much of that have you all started, and how's he doing so far?
So far we started some of the like introductory low-level things.
I don't know how to kick someone out.
Come on.
And we're gonna start talking about X and Y intercept. And right now a lot of it's just like very conceptual. So we haven't done a lot of like computation or like factoring and things like that yet. It's just like understanding.
Is that somebody else's
like what we're
call or something? I don't know what that is.
Yeah, I guess.
What does this Y intercept even mean? Like if this is a graph of elevation versus time. Understanding that the Y intercept.
Is that background noise in y'all's office?
Yeah.
I think you have, since you run the I think you have to mute them.
X intercept means pull back high when you reach.
Because I cannot. Okay.
We got
You should
it?
be good. Yep.
Okay, if everyone can mute, that would be great. And if you have questions, don't hesitate to jump on or use the chat function. Either way, as we go through it. So anyway, I was saying we're capable of doing large or small projects. So a little more background on our company. We're in the memorial business. I mean, by that I mean the cemetery business. We do custom headstones and columbariums and mausoleums and so forth, and a whole separate sales team focuses on cemetery work, where I focus on the commercial work with the architects, general contractors, and installers. Again, you can see a couple of private mausoleums and the detail that go into these solid stone structures. We'll use the same fabrication skills for commercial work. We have a bronze foundry as well. We're capable of doing all sorts of bronze signage. A lot goes into the memorial side of the house, but we can do commercial bronze inlays and signs and so forth, whatever you're trying to say in bronze. We have the capability of producing that. We're very committed to sustainability. It's no secret we're in the extraction business, but how we go about it is very important to us. We want to make sure we have 100% utilization of our materials coming out of our quarries and shops. We can produce crushed stone and riprap, can produce jetty stone and blocks, but our main fabrication is for commercial memorial work using architectural blocks that you see on the bottom right. We're very committed to the ANSI NSC 373. This is a third-party consensus multi-aspect standard that evaluates how environmentally friendly our quarrying and fabrication practices are. It's not one and done to get certified. We have to reapply each year, and every 3 years we have on-site audits. 4 of our quarries and our main fabrication facility in Minnesota is certified through this program. Quarry reclamation is a part of the sustainability journey. What happens to these sites when we stop extracting material? Can they be used as a wildlife refuge, water reservoirs, biking, hiking trails, and so forth, so the community can benefit in other ways besides having an operating business in the area. We acquired a lightweight stone panel business several years ago that is fabricated and headquartered down in Texas. We take a regular 3-centimeter size slab, apply a honeycomb backing to the back of it, and slice the slab in half. And as a result, we can get thin panels that weigh approximately 4 pounds a square foot. These are ideal for applications, vertical applications where weight is a concern. It's an anchored cladding veneer that you can use for lots of different types of materials. So that's what Cold Spring does. My email is up there if you need to contact me. But any questions or thoughts on the introduction before I shift into our continuing ed? We are going to offer continuing ed credits. My understanding of the plan is you'll report to Christine your attendance and AIA numbers, and then she'll send me the sign-up sheet for credit for today's program. So if there's no other questions or thoughts, I'll go ahead and start with the learning objectives. I want to talk about the formation of stone, ASTM testing. The bulk of the program is going to be about quarrying and fabrication. Then we'll look at the stone in different applications for landscaping and building designs. So if you think back into your school days, you may remember formed in 3 broad categories. Sedimentary material is where sand is pushed down into the Earth's surface, and through heat and pressure, it solidifies into stone, typically done in layers. Sandstone, limestone, onyx, and travertine are formed this way, sometimes with more moisture, sometimes with less moisture in the formation of the stone. If the Earth continues to cook sedimentary material, it can recrystallize into metamorphic material. So marble is formed from limestone shale into slate, sandstone into quartzite. It's just additional heat and pressure from the Earth, and it's recrystallized sedimentary material. If the Earth continues to cook, the material can turn to a liquid state or lava. When lava cools and hardens, igneous materials are formed. This still happens today. I saw on the news recently, I think in Spain, there's an active volcano going on, and it's igneous materials being formed from the Earth. Igneous materials, or granite being the most predominant igneous material. Granite is made up primarily of 3 different minerals: quartz, feldspar, and mica. And it's the combination of these minerals that give the granite the colors and the veining and the variation in it. Some granites can be very consistent. Some can show a lot of variation. It just depends on the mineral composition. Any type of igneous stone that we cut and polish commercially, we refer to as granite, though geologically speaking, they are igneous, but they may be slightly different than a granite. They may be labradorite or some other type material, but commercially refer to them as granite. So any questions on the formation of stone materials? And again, hop on, ask a question, or use the chat function and ask away if there are any questions or comments as I go through the program. The next section is quarrying granite. What we look for is a solid deposit of material, and we do this through bore testing. We drill down and test the material, what kind of quality it is, what kind of color, if it's marketable, and so forth. We go through a permitting process, and then we start the quarrying process. We do that by removing overburden on top of the deposit and try to work the quarry down into a flat floor. And from that, we step it down into shelves. And the way we go about doing that is cutting in a keyway and dropping the quarry slabs and developing the quarry that way. So the way the slabs are dropped, we either saw them with wire saws or we drill and split them. You can see the textured walls have been drilled and split, and the smooth walls have been sawn. So for setting up the saws, what we do is we drill down into the material both horizontally and vertically, and we try to connect these holes, or we could do it horizontally and cut the bottom, or make a vertical cut. What we do is connect the holes, blow a string through it, tied to the wire saw blade, pull it through, and connect it to the saw. These saw cuts can be quite long. They can be 20, 30, 40 feet across, depending on how we're developing the quarry. We want to keep these cuts as square and as possible. We don't want them bowing. Sometimes site conditions will make the saw bow some. We're trying to prevent this, and we're trying to keep the blocks as square and as much as the cube as possible. You can see the saws are set up here. There was a hole drilled in the back and a hole in the bottom, connected it, and the blade is running through here. Two parallel saws is pulling it back on the track. When they get to the end of the track, they'll shorten the blade and pull it through again, and eventually making slices through this to drop what we refer to as quarry slabs. We do that by pulling them over, pushing them over, wedging them out. We set some buffer material down, and boom, we drop over the quarry slabs. What we're trying to do is produce a loaf, which is around 20 feet by 5 by 5, and from that, we want to have a block that is roughly 5 by 5 by 10. So you'll hear me talk about it, the average block size is 5 by 5 by 10. You can see we drill and split them and also saw them to produce it all the way down to a block. The drilling and splitting is a little bit different. We do this hydraulically. We drill down into the material. We can do it on the slabs on the ground to produce the blocks and loaves, or we can do it on the high wall. So once the drill holes are in there, we'll put in wedges and then hydraulically split the material, and it all split right in line. And so usually it's a combination of both of these methods. You can see, again, the drilling and splitting on one wall and the sawing and the swirl marks on the other wall, adjacent wall. We can't crisscross the saws, so usually on opposite walls, the opposite procedure is taking place. The question about any of the blocks being quarried out of the pit. Okay, once we get the blocks, we ship them to our fabrication facility, and we slab them, and we finish them, and we cut them to size and bundle them and ship them to the job site. This particular block here is going through another wire saw that's coming around, and it's basically slicing what we call a rough back off the block. We're squaring that block even more. It's sort of like cutting crust off the bread, if you will. So the way we slab the blocks is one of two different ways, either with a wire saw like you saw in the previous picture, or with a shot saw. And you can see this giant arm here is operating the saw blade of the shot saw, and I'll explain the differences. The wire saws are set up to cut the thicker material, so 2 inches and above in thickness. The wire saws are used. We can do it in a single cut like you saw in the couple slides earlier, or we can set up and do multiple cuts like it's set up here, and it goes down. These blades are going through. You can see the water being used to cool the equipment and save the equipment and the blades. And it drops down about a foot an hour. So after 5 or 6 hours, one block could be sliced into thicker slabs and ready for finishing and cutting. Now the shot saw works a little bit differently. You saw the outside of the house with that giant arm, and what that arm is doing is moving these steel blades back and forth. And this looks like a giant bread slicer. It's moving back and forth, and it's slicing down through these entire blocks. But the difference is it takes about 2 or 3 days to get through the blocks. But once a series of blocks have been set in there and go through, we can have dozens of slabs. Now, these steel blades are smooth, and so they don't look like a wood saw where they have teeth in it. So in order to create the friction to cut the stone, we rain down the steel grit with moisture, and the steel shot or steel grit gets in there, causes the friction, and the blades are able to slice through, the granite. Wire saws are used to do specialty cuts as well. You can see on the right, it's doing these channel-shaped structures. These are used in metal fabrication, industrial uses, but the one on the left is cutting radius slabs. So I get asked the question a lot, if we're cladding a building and the building or the wall has a radius in it, can we use the same detail around that radius? Well, you can. We just have to produce radius slabs rather than flat slabs like you've seen in the previous slide. So whatever that radius is, we have the ability to produce those sort of slabs. For all flat slabs, when they're being cut, we send them to the bridge saws to make straight cuts. Bigger blades cut thicker material. The tango saw, think of it as 2 to tango. This is 2 parallel blades that can go through, and we program the saw to make a bunch of parallel cuts. And with 2 blades, it'll cut it twice as fast, obviously, and we can rip through thin material pretty quickly with the tango saw, cutting up paving or cutting up small sills and things like that. Thicker blades or bigger blades are used to cut thicker material. The slab on the left here is all marked up, ready to go to the tango saw. You can see those parallel lines that the tango saw will get in there and cut that up pretty quickly into the small pieces. If it's anything besides a straight cut, the water jet and the router saws are used to make those cuts. The water jet is a fantastic tool. So if we were going to cut a piece of stone in the shape of the state of Virginia, we would use the water jet, this program, to how big it needed to be and make that cut. And it can do that precision, like you see on the water feature being built on the left there. It can cut really any type of shape, and then you can put the puzzle back together to whatever it is, these skewed diamond shapes and all that the water jet is able to cut. Now that bottom right answers the question, well, how thick of a material can we cut on the water jet? Well, the answer is pretty thick, 3, 4, 6 inches maybe. And the top gets very crisp and very clean, but the bottom can become more jagged. So it may require some handwork, or maybe an application where a jagged cut at the bottom is okay and will work. But you can see how clean and crisp the top cut is compared to the water loses pressure as it goes through the material with thicker material. So the router saws do all and the CNC saws do all the 3-dimensional work. So when you guys are designing in 3-dimensional and Venner files and so forth, we can take those files and program them into our router saws, and then they can cut the 3-dimensional shapes that are needed for the job. So whatever kind of shape they are. Now, the wire saws may trim the blocks down some, but then the router saws come in and fine tune it, put those radiuses on it, those slopes on it, and so forth, and run it through on the CNC equipment. The 5-axis saw is a wonderful tool for carving. This is a weeping angel on the memorial side of the business, but the same thing can be used to produce commercial work. This is an interesting job on the bottom right. It's a water feature being built, and those slabs on the bottom right are not only radius, but they're also cone shaped, and they're also stair stepped on the outside of the slabs, and each slab needs to be set plumb and level to the next one. Water is going to flow over it, and the water is not going to lie. So the 5-axis saw has the capability for that sort of precision to be able to cut like that and produce a job with that sort of detail. Now, not every job has that level of detail. You can do radius curving and architectural designs and so forth with the 5-axis saw that you see in the other pictures. Questions on any of the sawing and the cutting of the material? So if you remember, I told you the blocks are roughly 5 by 5 by 10. And so the slabs we work with are 5 by 10, but it doesn't mean for some materials we can't get oversized pieces that will allow us to get bigger pieces. This particular job you see here, this slab is 22 feet long by 8 feet across by 8 inches thick. It's actually a roof of a mausoleum. So some quarries will allow us to produce blocks that big. Most will not, just because of the way they're formed by the earth. I can't extract a block that big without it breaking. But for purposes of standard materials, it's really a 5 by 10 slab that we're working with. And so anything that we're cutting usually is coming out of that 5 by 10 slab. There's standard thicknesses as well, and we would encourage designers to design with the standard thicknesses. If you go outside of it, it's not a problem. We either have to reset saws to make special cuts in the block, or take pieces and grind them down, which is just more costly for the job. So you can see the thinner materials, again, cut on the shot saw with a tighter tolerance than the thicker material plus an eighth minus the 16th cut on the wire saws. And the reason the bigger tolerances with the wire saws, the wire blades over time wear thinner, and so that increases the thickness of the slab. And that's not from one side of the slab to the next, but it's from slab to slab to slab. We get about 5,000 square feet of cutting out of a wire saw. Then we retip it one time and get about half that. And then after that, we put it in the metal recycling bin because it's too stretched out to use anymore in fabrication. Questions on any of the thicknesses and sizes and so forth? Finishing, there's lots of finishes that are available in natural stone. All these materials that you're looking at, all these pictures of the same material, and the materials can, the finishes can change the look of the material quite a bit. So if you're looking right in the two in the center, the rub and sand is very light and lightly textured, where a hone is kind of darkening the material and making it look very different. So it's important to specify the correct finish with the correct material. You want to make sure, like for walking surfaces, exterior paving applications, you would use a textured or a thermal or diamond 10 would be ideal because it's not too slick and not too textured, where a polished or honed would be too slick, and a split and pitched and diamond 300 would be too textured for a walking surface. So again, you want the correct stone with the correct finish on it. The way we apply different finishes, the polishing and the honing and the antiquing and so forth, we run it through a polish line. So each one of these housing units that you see in the picture houses a diamond grit sandpaper, starting with the very coarse and going to a very fine buff pad. Smooth polishing pads are used to get a smooth finish. Textured polishing pads are used to get a more textured finish, like an antique or leathered finish. And if we wanted polish, we run it all the way through. If we wanted honed, we run it about 2/3 of the way through, and it'll give you a matte finish rather than a high polish finish. Thermaling is where we wet the material and hit it with a torch, and that rapid change in temperature cracks and pops the surface, and it creates a consistent texture on it. And that's kind of ideal for exterior paving applications. Most granites and bluestone take a nice thermal. Sandstones and limestone and slate and stuff, you can't thermal, just it won't go through that process. Some granites, like gold colored granites, you wouldn't thermal because of it changes the color. So it takes that nice gold color and turns it to pink or peach, and you may not want that, what the torch does to the surface of the material. So for more textured finishes, we can split the material. You see the guillotine there on the top right, where we're sending slabs in there, and that hydraulically comes down and splits the material right down the line. Some materials will be more concave and convex, where others may split a little cleaner, depending on the mineral composition. If the material is too big to fit in the guillotine splitter, we'll pin and feather it, and that's what you see on the big block. We'll drill down in there and put the pin and feathers in the hole, and then start beating on it with the big hammer. Get the biggest guy in the shop to just go right down the line time and time again. And then eventually that block will split. You can see it on the bottom right where they pin and feathered and it split that block real cleanly through that process. Truncated dome pavers can be created as well. This is real important to our landscape architect friends. They use these for ADA applications.
I don't want to drive that.
Crosswalks and all. Are there questions, or is somebody unmuted? Any questions on any of the finishes? You can do different finishes and different pieces, and from piece to piece to create patterns and so forth. This is a good example here where it's just one piece of stone, and we finish. It's the Chesapeake Bay watershed. This is up at the aquarium in Baltimore. And so the bay and the ocean are one finish. The watershed to the bay is one finish, and the watershed to the ocean is another finish. And you can see the detail and how we can finally finish different areas within the same piece and create that sort of detail. So, any questions on finishing the material? We can do graphic work as well in stone, and we can do that through different levels of sandblasting. You see on the left, kind of the bigger letters would use a thicker stencil and a grittier sandblast, where the details on the right, bottom right, is a thinner sort of stencil and more fine. So think of it as like sandblasting something gritty like sugar versus sandblasting something fine like flour. And that's the difference in how we can get the images into the stone. Once we carve in the detail of it, then we'll go back in and highlight it or shadow it. So on the left, the lettering is stained black to shadow it, to create more contrast, where the columns on the right are highlighted with white and to create more contrast with the black granite. And then on the paving on the right is shadowed to create more contrast with the gray paving material. The way we do it is we create a stencil and cover the stone, and then we send it into the blast house. This is going to be rolled into where we do the blasting through that door on there, and we carve it all out, leave the stencil on it, and then stain the inside. And it's a number of passes, so we can do it like light, medium, heavy, all in the same color. It's just how many passes do we go over that stone. Some jobs you want it real contrasty, others you want it not as contrasty. And so we can control that by the number of passes of the stain. This is a great commercial job here. It's the Boston's Children's Hospital, and we highlighted different images to bring them to the foreground. We've shadowed images to push them to the background. We've not put any sandblasting on different areas to create the black stone to show that through, and then create all sorts of imagery down the block, up the wall, and we can do it. The computer will allow for the joints in the slab, and we don't skew the image. And it's a great example too of QCing it in the shop, which is on the right, and then installed in the field, which is on the left. We can turn the corner and do the edges of the material and so forth. So very complex, very detailed, with different levels of sandblasting that we're able to create. What we're very good at in the industry is carving and putting images on stone. What we're typically not in the industry is graphic designers. So we can explain how to do this in the stone, but we're not going to necessarily advise you and say, well, that dragonfly really should be a butterfly and it should be a little small. That's for the graphic designers to create, and then we'll be able to put it on the stone. So question with any of the graphic work. In terms of sampling, there's two ways we sample jobs. The first one is we get preliminary samples, and they just accumulate in our shop as we run material through different size samples and different colors and finishes, and we send them out kind of as a general idea of what the color and finish will look like. Approval samples are cut from current inventory when jobs go under contract. Usually they're set out in 3 12x12s to show the range of the current material and what the variations may look like. There's other ways to approve the stone as well. You can do mock-ups in the shop like we just saw. We can do really small ones. We can do really big ones. We just need to know in the specification what's required. There can be mock-ups on the job site for approval with the other materials. You can visit quarries, you can visit the shops. We just need to know what the expectation is how you want to approve the material, and we can certainly accommodate that, and that would be listed in the specification. We don't want any surprises. Some materials can vary quite a bit where other materials can be really consistent. Any questions on the sampling and approval and mock-ups and so forth? Different applications, certainly we can do interiors with wall cladding and flooring, base material and cladding for interiors, and mosaics on the floor can produce stone and tile thicknesses for thin setting applications. Exterior, both vertical and horizontal surfaces, cubicle work, different finishes, and you see on the top of the stone it's polished where the edges are split and the backs are thermaled, and the lettering on the blocks are highlighted, the lettering in the paving, some of it's shadowed, some of it's highlighted, some of the blocks are cut straight, others are cut at radiuses. So it's however you draw it, it's how we cut it. If the face of the stone has a tilt or slope to it, we can grind it down, slope it 1 degree, 2 degrees, whatever it needs to be. It's all how it's designed. We're kind of literalist. If it's drawn in a radius, we're going to produce it as a radius. We're not just going to assume someone's going to chop pizza, cut it and wedge it in there. We will actually produce it in a radius. Plazas with paving and curbing and wall cladding and graphic work. Sometimes artists get involved, and the creativity goes crazy, and you want blocks out of boulders and columns out of blocks and all sorts of wild ideas, and we do love that, and our fabrication folks follow along and create it just as it's the design is conceived. This is a great job on the router saws with the angles and the radiuses and unique shapes, and then all coming down into basic tread material. The Eggman job in California was a zero waste job. So it started at the quarry with certain quarry slabs to produce the slabs, to produce the rings, to make the Eggman with the bases in the middle of them. And the outside of the slabs are used to create the outer ring, and any drops are used for the cobblestones. This is a bioretention pond, the zero waste and stormwater controlling, pretty wild project in California. But if you don't have Eggman, that's fine. We do a lot of benches and paving and treads and lots of other things. You can notice the change in finishes to create the pattern in the paving here. So lots of options in stone. Granite is ideal for water structures and different water applications because of the durability of granite compared to other type materials. Questions on any of the applications? For anchoring, there's really two schools of thought. The relief anchor supports the weight of the stone, and the restraint anchor holds it to the wall. Usually it's a combination of both anchors, even on one piece of stone. You want to make sure you're specifying the correct stainless steel anchor and the correct setting materials with it, so it performs as it's designed to. There's lots of different types of anchoring systems that are available in the market. These are a lot of kerf anchors that you see, and some wire tie anchors and dowel rods and stuff. So you want to make sure you understand and you're working closely with the suppliers to detail the anchoring systems. Interiors for cladding can use wire tie type anchors, where exteriors are more kerf anchors with kerf slots in the stone to accommodate the anchors and so forth. Blind anchors are used to support the back of the stone where maybe edges are exposed in a rain screen, or maybe the stone needs to be supported from behind for a soffit application, or the bottom of the stone is exposed. The type 31 anchors can be used as both a restraint and a relief anchor when they're detailed properly. For handset cladding applications, usually, well, always shop drawings require an engineer stamp. Most fabricators are not engineers, but they can sub out that option. Sometimes installers sub out the shop drawings, so it's all detailed properly for going up multiple stories in a building. There's kind of three rules of thumb with anchoring. It's the size of the material, the location on the building, and the location of the anchor. When one changes, usually all three change. You all know this better. Wind loads and corners are different, and changes in geometry are different than flat surfaces. And so the engineer just needs to work through all that so everything's properly detailed for the fabricator to have the anchor slots and the proper anchors provided. And so cladding, there's cladding on the left. Cladding applications have soft joints for slight movement of the material, whereas masonry veneers are hard joints, detailed more like brick. Stone masonry is available and can be produced in all sorts of thicknesses. This particular picture shows just the thickness of a brick, but it could be 8 inches. It could be 18 inches for a masonry veneer, just depending on the project and how it's detailed. Wall ties are used not necessarily to support the weight of the stone, but to hold the sections of the wall together. Questions on any of the cladding and anchoring? ASTM, there's lots of testing that's available for stone materials. You want to make sure that's included in your specification. Absorption is a very important one. Granite performs with absorption, but very low. It's much less porous than other materials, but not all granites test the same. Fine white grain granite can typically have a higher absorption rate, and what that means is where the stone comes in contact with the ground, moisture can get in it, and the stone can look wet longer than you may think it should, or your owner may think it should. So it's important to understand absorption rates even between different granites. The way this test is done, they weigh the material, submerge it in water, and weigh it again, and then see how much water's penetrated into the stone. Compressive strength is another important test. If you think of concrete sidewalks for your building are usually 3,000 or maybe 3,500 PSI. Well, granite starts about 17,000 and goes up to about 30,000 PSI. So in terms of compressive strength, granite is very hard, very durable, especially compared to man-made type products. Flexural strength and modulus of rupture or other strength tests that are usually included as well in the ASTM package of testing that should be available for materials. Coefficient of friction is a slip-resistant test on what materials are too slick to use for walking surfaces, particularly exterior applications. This test is done both wet and dry. But remember that polished and honed and antiqued and all these sort of shiny stones should not be used in exterior paving. The ideal walking surface for exterior applications is thermal or diamond 10 or diamond 5, rub and sand, those type of textured finishes for exterior applications. What you're trying to avoid is failure of material and slip hazards and so forth. You want to specify the correct material and the correct application. This job is what I refer to as a hot mess. Moisture is leaking out of the sandstone. This could have occurred at the quarry where moisture is in it and the material needed to be kiln dried, or it could just be a material that's not durable enough for exterior applications. This may look great, or your owner may be doing backflips thinking, oh my gosh, I thought it was all going to be the same color, similar color, and it's all over the road with tans and pinks and buff colors. So you want to understand the color variation of the materials that you're selecting. Marble erodes over time from year to year and decade to decade in exterior applications, where granite stays much more crisp, much more durable, and can stand the test of time. Questions on any of that? Last section, some pricing considerations. In terms of detailing, head joints are the most practical way to design cladding applications. Cork miters are done quite often. This is when we remove the little point in the corner to prevent it from chipping, and we can have a miter joint in vertical cladding applications. Rustication are much cheaper than reveal joints, but however you detail it, we can certainly produce it that way. Hook joints can be very expensive, where we need to go in and remove the extra waste material, so it's extra labor and extra material that would be required for a hook type joint, but it can be produced. You want to make sure edge details are specified and detailed correctly. This looks like the job where they went to the slab yard and just stuck up some materials. It doesn't look right to me. The owners may love their building, but to me, it looks like they took a shortcut here, and you want to prevent that on your projects. In terms of sills and coping, we can cut the material, like I said, any way you draw it just about, but any sort of slope where it starts like at 4 inches here and goes down to about 3 1/4, something like that. To cut this slope can be expensive, whereas if you have a rectangle and you tilt it, it's a much more practical way to detail it. But, you know, if it requires a roof pitch or whatever slope on a sill, on a cap, on a block, we have the ability to do it. It's just more labor and cutting required for the material. Cubicle treads are a more expensive option than treads and risers, but some jobs just require big buildings and prominent buildings. They have cubicle treads, and that's just the way it is, and we do it all the time. But if you're looking for some cost options to save on the material, treads and risers may be an option for you. So in the end, you just want to make sure your anchors and edge treatments and freight and shot drawings and engineering and testing is all included, taxes and whatever, if insurances are included with suppliers and subcontractors. In terms of duties and custom fees, I've been hearing crazy stories about trying to get materials brought into the country. Be aware of that. Containers are at a premium, and ports are bottlenecked due to pandemics and our different administrations' policies towards importing materials. So don't get caught, don't get back charged on different projects in terms of that. Please get your arms around all these items to make sure that the stone is designed correctly, budgeted, it gets bid accurately and installed on the job with no change orders, and the stone job looks great. Here's my contact information again. Like I said, I've been doing this a while. I'm only down in Richmond. I'd love to come see you guys when the world opens up, but I can help. You can contact me, call me, email me, or invite me up. I'm around in DC more than you realize, but I'm here to help you guys. So for continuing ed, again, we're going to send the AIA information to Christine, and she'll send the form in to me. But I appreciate y'all's time. Any final thoughts or questions that y'all may have?